Mars has long captivated human imagination, and recent discoveries have only deepened our fascination. New evidence suggests that Mars may have once had conditions similar to Earth, providing valuable insights for future exploration. In this video, we'll delve into three major revelations: the identification of salt deposits in Terraforming, an innovative method of terraforming Mars using dust nanoparticles, and the discovery of an ancient lake bed in Corallis chaos. Let's dive in. Hello, and welcome to ZE. Please don't forget to subscribe and hit the bell icon. The European Space Agency's ExoMars Trace Gas Orbiter recently captured a striking image showing what looks like a purple mermaid in Mars's southern region. This violet tint comes from chloride salt deposits in an ancient riverbed. The area, known as Terraforming, or Sea of the Sirens, is significant because these salts provide strong evidence that liquid water once existed on Mars billions of years ago. Similar to how chloride salts form on Earth when water evaporates from lakes or seas, it appears that the same process happened on Mars. The type of salt discovered here, resembling Epsom salts, consists of magnesium and sulfuric acid. It likely formed when magnesium-rich water from underground mixed with surface sulfuric acid. This discovery suggests that Mars was once warmer and more humid. The presence of these salts in a dry riverbed indicates that water once flowed across the planet's surface, potentially creating environments suitable for life. These salts likely formed through repeated cycles of water evaporation and rehydration, which required stable and relatively warm conditions. This implies that Mars may have had an environment capable of supporting life. The location of these salts in Terraforming adds to the intrigue, as this region is part of Mars's southern highlands, an ancient, cratered landscape shaped by impacts. The discovery hints that this area could have been part of a vast system of lakes and rivers that once covered the southern hemisphere of Mars. For those interested in the possibility of Martian life, these salt deposits could preserve organic molecules or other biosignatures, providing direct evidence of past life. This discovery also raises questions about Mars's climate history and how it lost its atmosphere and water. By understanding these processes, scientists could determine whether Mars could be made habitable again, either through natural means or human intervention. As the dream of colonizing Mars inches closer to reality, scientists are working to overcome the massive challenge of making the planet livable. One of the newest and most promising ideas is the concept of terraforming Mars by using dust nanoparticles. Developed by researchers at Northwestern University and the University of Chicago, this idea proposes that Mars could be warmed by releasing engineered dust particles into its atmosphere. These particles, made from materials already present on Mars, could boost the greenhouse effect and raise surface temperatures by over 30 degrees Celsius. While the idea of terraforming Mars isn't new, earlier proposals were often considered impractical due to the enormous resources required, such as transporting large amounts of greenhouse gases from Earth. However, this new approach is more realistic, as it uses Martian resources. Mars's surface is rich in dust, particularly iron and aluminum. By processing this dust into nanorods, researchers believe they can create particles that efficiently trap heat. These nanorods, which are similar in size to glitter, would be dispersed into the Martian atmosphere, where they would reflect sunlight and trap thermal infrared radiation, enhancing the planet's natural greenhouse effect and gradually warming the surface. According to researchers, releasing 30 liters of these particles per second could create noticeable warming within months. Importantly, the process is reversible. If unintended side effects occur, scientists could simply stop releasing the particles. The practicality of this idea is a major advantage. Unlike other methods of terraforming that require importing materials from Earth, this approach relies on Mars's natural resources, making it more feasible. Additionally, the amount of material needed is far less than in previous proposals. Scientists estimate that 700 million cubic feet of Martian dust would need to be processed annually to produce the necessary nanoparticles, a small fraction of Earth's yearly metal production. Despite its potential, the idea of warming Mars with dust nanoparticles raises ethical and scientific concerns. The long-term impact of adding nanoparticles to Mars's atmosphere is unknown, and they could affect the climate in unpredictable ways, potentially disturbing any existing ecosystems or complicating future exploration. If microbial life is discovered on Mars, terraforming could also endanger these organisms. Before any large-scale terraforming projects are undertaken, the ethical implications of altering an entire planet must be carefully evaluated. Although terraforming Mars with dust nanoparticles is a forward-thinking idea, our understanding of the planet's potential for life is rooted in its ancient history. The recent confirmation of a long-dried lake bed in the Corrales Chaos region provides important new clues about Mars's geological and hydrological past. This discovery, made by the European Space Agency's Mars Express orbiter, offers strong evidence that Mars once had significant bodies of liquid water, which may have created a stable environment suitable for life. The lake, known as Lake Eridania, was larger than any current lake on Earth, covering an area roughly the size of Egypt. Located in Mars's southern hemisphere, this region is defined by its rugged terrain and intense volcanic activity. Images captured by the Mars Express orbiter show a landscape shaped by both water and volcanic forces. The lakebed is what remains of a much larger body of water that existed about 3.7 billion years ago, at a time when Mars had a thicker atmosphere and a more moderate climate. The discovery of water in this region suggests that Mars was once a much more active and potentially habitable planet. A striking feature of this area is the network of channels and valleys crossing the landscape, providing clear evidence of how water helped shape Mars's surface. The lake that once filled the Corrales Chaos Basin was likely fed by a complex system of rivers and streams from higher elevations. As Mars's climate changed and its atmosphere thinned, the lake evaporated, leaving behind a dried lakebed and intricate channel network that is visible today. Studying these remnants offers scientists a unique opportunity to learn more about Mars's geological and hydrological history. By analyzing the sediments and rocks in this area, researchers can gain new insights into the planet's climate history and the processes that led to its loss of atmosphere and water. The identification of salt deposits in Terraforming, the proposal to terraform Mars using dust nanoparticles, and the confirmation of an ancient lakebed in Corrales Chaos all suggest that Mars was once a more dynamic and possibly habitable world. As we continue to explore the Red Planet, we not only expand our understanding of a distant world, but also consider the possibility of life beyond Earth. The question of whether Mars once supported life, or could in the future, remains one of the most captivating scientific challenges of our time. In conclusion, the recent discoveries on Mars provide an exciting glimpse into the planet's past, present, and potential future. The evidence of salt deposits and ancient lakes points to a time when Mars might have been habitable, while innovative ideas like terraforming using dust nanoparticles offer hope for making the planet livable once again. As humanity's fascination with Mars deepens, so too does our understanding of its complex history and the possibilities it holds. These findings not only spark our imagination, but also challenge us to consider the broader implications of exploring and potentially altering another world. The quest to uncover whether Mars ever supported life, or could one day, remains a profound and tantalizing question, driving both scientific inquiry and our broader exploration of the universe. Thank you for watching and see you next time.